Ever do some experiments, get some weird results, go back to your calculations, and realize you were off by a factor of 10? Here are some tips to help prevent that from happening again.
Often in biochemistry, we're dealing with really tiny volumes and really tiny quantities and really low concentrations. And so in order to work with these, we typically use metric prefixes like milli, thousandth, micro, a millionth, and nano, a billionth. And so these can be kind of harder to work with than some of the more traditional ways that we're used to thinking with units in terms of like kilo and mega, maybe centi, deci, but the same type of idea holds, except that we're going a lot smaller. It can get easy to kind of get jumbled up, not remember whether you're supposed to multiply or divide, to lose track of numbers in scientific notation. And so I just want to go over some tips and tricks and some um, reminders and cheat sheets and things like that to help you keep track and not get lost in those numbers, because when you get lost in those digits, it can be a really tiny error that then messes up the entire experiment or changes your interpretation of the results. So let's start with just some intuitive thinking, because as I said, it can be kind of hard to think about things in a really tiny scale. Let's start by thinking about pizza. We can think about pizza, right? So imagine you had a pizza and then each of those pizzas has certain number of slices. We can so we can say like if a pizza has 12 slices, well then that's the same thing. Saying 12 slices or saying one pizza, that's the same thing. And this is the idea behind dimensional analysis, is that you can then line up those different interconversion units and use them to convert between different things. And so I have much more dimensional analysis in another post, but you line things up so that the units cancel out. And this is the same sort of thing. You can do this exact same thing with these metric prefixes. But there's also the shortcut that because these metric prefixes are dealing with they differ by units of 10, then we can actually just make things easier and move our decimal place. And so more on this in a minute, but let's get back to that intuition to start. So saying that we have 12 slices per pizza is like saying that we have 1,000 milliliters per liter, or that we have 1,000,000 microliters per liter. But pizza slices are easier to think about. In case you're wondering, like, so a microliter, so as I said, it's like a millionth, micro is millionth of a. We use this a lot in biochemistry, and so that's often what you're pipetting with, like one of those normal like micro pipettes. You're thinking in terms of microliters, and so the biggest size we typically do with those is like 1,000 microliters, which is a milliliter, and there's like 15 milliliters in like a tablespoon if you need some sort of sense, but basically a microliter is going to be really small. One of those normal Eppendorfs, that's about 1.5 or 1.8 milliliters, so like 1,500 microliters. So just so you have a rough sense of the type of volumes that we're working with. But again, it's easier to think in terms of pizza, so let's go back to in terms of the pizza. So you have a certain number of slices per pizza, and then you have, say, a certain number of pizzas. So maybe you have like a stack of pizzas boxes in one of those carrier bags, and then you have several of those carrier bags in a pizza delivery person's car. So now you say you want to convert between those different things. So you want to convert between, say, like the bags and the boxes and the slices. Similarly, we might want to be converting between like grams and micrograms and nanograms and liters and microliters and milliliters and all of these different things. So when we're actually converting our amount of stuff, if we're thinking in terms of less stuff, our number should get smaller. So for example, when we're talking about how many pizza slices are in that car, well, in that car, you have those bags, and in those bags, you have those boxes, and in those boxes, you have the pizzas. And so you have lots of pizzas, and then each of those pizzas has lots of slices. So you've got a lot of slices in that car. But if you're just thinking about how many slices you have per pizza box as opposed to slices per car, well, that's going to be a much smaller number. Similarly, there are going to be fewer molecules in a microliter than there are in a liter, and there are going to be fewer molecules in a microgram than there are in a gram. So if you're thinking in terms of like a smaller quantity, so say you want to know how many moles are in a microliter compared to how many moles are in a liter, well, now your number is going to be a lot smaller. But when you're thinking about the same amount of stuff, just in small terms of smaller units, then your number should be bigger. So if we're thinking about that same car and we want to say, okay, well, how many bags are in that car? There might be a few bags in that car. Well, how many slices are in that car? Well, each of those bags is pizzas and each of those pizzas have slices. So we're thinking in terms of these smaller units, but in this case, we're not changing the amount of stuff, just the way that we're thinking about that stuff. And so now our number should be bigger. Similarly, if we're converting between like grams and micrograms, we're going to be multiplying. We're going to be getting a bigger number because they're going to be going to smaller things, but we're talking about the same amount of stuff, but just in terms of smaller units. And we can go all the way down, so we can say there are more micrograms in a gram than there are milligrams in a gram. But then there are the same number of micrograms in a milligram as there are milligrams in a gram. So things can get we can convert between these at all these different levels. And these metric prefixes, knowing the conversions between them is going to be really helpful because these are going to be factors of 3. So we don't really deal much with deci and centi. I guess we deal centimeters sometimes in science, but thankfully we're typically dealing with these all the ones that are multiples of 3. So to convert between these, we just have to go by a multiple of 3. So you're either multiplying or dividing by some factor of like 1,000. As I mentioned, we typically are in this like milli, micro, nano range. Sometimes we deal with molars. That's typically like a stock solution. A more concentrated version than we're finally working with. We're finally working with these. Just a note that this micro, the symbol for micro, is going to be this Greek mu symbol. And so frequently that I actually have my keyboard. I set it so that I have a keyboard shortcut where I can switch to the Greek alphabet to quickly write it. There's also like a shortcut if you do like Alt 230. But that's more keys than what I do. It's just like Option spacebar and then whatever Greek letter I want. So you can set up your keyboard to do that if it's something that you use a lot. So when we deal with these units, we can think of them in terms of going to the base unit. So whatever we're putting this in front of, so whether that's a gram, whether that's a meter, whether that's a liter, whether that's a molar, we can stick this in front of that. And then we can talk in terms of how much you need to multiply or divide by to get to that base unit. But then we can also be converting between these different units. Because they're all spaced out by 1,000, then we can convert between these by going by 1,000 and between them to the base, and then to by going by whatever their base, whatever the number in front of here is. So I think it's easier to just like explain it with examples. But first of all, we need to talk really quick about scientific notation. So it can be hard to it can get easy to get lost in scientific notation and talk about like billions and how many zeros does that have. So one of the great things about scientific notation is you have these small numbers, they're easy to convert between. But one of the downsides is that you're kind of hiding a lot of detail. And so you might think, okay, well, 10 to the third versus 10 to the fourth, there's just one little number difference, but really that's a factor of 10. And so you can easily get off. And so let's just talk about it on the same page. So basically with scientific notation, you have some sort of number multiplied by 10 to another number. So we'll call that other number n. I say multiply, but if n is negative, it's the same as dividing by 10 to the positive form of n. So when n is -3, so you have some number times 10 to the -3, that's telling you the same thing as dividing by 10 to the third. And then 10 to the third is going to be 1,000. So n tells you the number of zeros after the 1. So 1 times 10 to the third, well, that's going to be 1,000. You have 3 zeros after the 1. And so it's after the 1, not after the 10. That can be one place that it's easy to add or subtract a 0. It's because these decimal places represent factors of 10, and then therefore tells you how many places to move your decimal points. So if n is positive, your number is going to get bigger, and you're going to move your decimal point n places to the right. So if you have 10 to the third, move that decimal point 3 places to the right, adding in zeros as needed. 10 to the sixth, and this is going to be a million. You would go 6 places, and so now you're adding in zeros. If n is negative, your number is going to get smaller. Remember, now you're dividing, so you're going to be multiplying by your decimal, moving your decimal place n places to the left, and you're getting into these adding zeros as needed. We typically only put one digit before the decimal place. So we're writing 9.43 times 10 to the third instead of 94.3 times 10 squared. But this can make it confusing when you're trying to do with these unit conversions. So say you had a number that you had 94.3 times 10 to the third. Well, okay, well, that would be like 1,000, like a kilo, right? But then if you have you had to write it as 9.43. Well, then you are, when you go to convert between units, now you're not in a multiple of 3, you're not in one of those standard prefixes, and so this can be an issue. So you might see sometimes like engineering notation, which actually it'll keep those numbers in front, so that it keeps the 10 to one of the these common metric prefixes. Just a note. But be careful when you see things like 10 to the fourth or 10 to the fifth, when you're somewhere in between those 10 to the third, 10 to the sixth, 10 to the ninth, and the inverse forms of those as well. So just be cautious with that. Another way that scientific notation is sometimes written is with this like E notation, where E stands for E to the 10 to the. And so you would write your number, E, and then the number that you want to multiply by 2 or factor of 10, so n. For example, 9.43 times 10 to the third can be written 9.43e3, and 9.43 times 10 to the minus third can be written as 9.43e minus 3. And so you might see this in calculators, use this in Excel, and that sort of thing. Just a note of caution, remember that the e includes the 10, so don't write 9.43 times 10 to e to the 3, because now you're adding an extra 0. And that confuses me sometimes, so don't get confused. Okay, so now that we're all on the same page with the scientific notation, we can talk about how we can use it with these small units. What can get tricky is that when you're going between, like going from smaller things to bigger things, or going from bigger things to smaller things, we have to keep in mind that idea that if we're talking about less stuff, our number should get smaller. If we're talking about more stuff, our number should get bigger. But if we're thinking about the same amount of stuff, just in terms of smaller units, our number should get bigger, and vice versa. So for example, if we want to go from milli to micro, so remember that there are 1,000 microliters in a milliliter. And so if we want to go from a milliliter to a microliter, we're going to multiply by 10 to the third, so multiply by 1,000. And if we want to go from a microliter to a milliliter, well, now we're going to have to divide by 10 to the third, divide by 1,000. We can draw all this out with dimensional analysis. So if we want to convert, say, 50 micrograms to milligrams, well, we can see that a microgram is going to be 1,000th of a milligram. We can line things up so that our micrograms and our milligrams are going to, these are equal to 1. So we can set up this as this factor of 1. We can multiply by a factor of 1 without actually changing this number. And then we line things up so that our units cancel out, leaving us with this being 0.05 milligrams, which we could have gotten by recognizing that there were 1,000 by recognizing that a milligram is going to be 1,000 micrograms. So our numbers are going to be getting smaller if we're talking in terms of milligrams than if they're in terms of micrograms. And so we're going to be dividing by that 10 to the third by 1,000. So we move our decimal place 3 points to the left, 1, 2, 3, add a 0 to get there. Another thing about scientific notation as well is that it's really good for dealing with significant figures where you have um, trailing zeros. So if you have zeros at the end and you're not sure whether that's significant or not, well, in scientific notation, it's definitely going to be significant if those zeros are included. And so more sig figs in another post, just a note here. So yeah, so these were going between with 1,000, so with 10 to the third, if you go with 10 to the sixth, well, now you can go between a microgram and a gram, a nanogram and a milligram, etc. And so the same sort of idea, you can do the exact same calculations, but go between units that were further apart. And so as long as you know how far apart they are, then you can do these conversions, and you can do it with just by moving your decimal place, thanks to scientific notation. So you can do this between other prefixes as well. Just remember which way they are. And if you're unsure whether to multiply or divide, write it out and make sure that your units are canceling out. We all like some shortcuts, right? So remember, go back to the dimensional analysis, make sure everything cancels out. If you're unsure, if things don't make sense. But here are just some shortcuts. So one is to recognize that when prefixes are the same and you're going to be dividing them by the same factor of 10, those prefixes are still going to be the same. So often concentrations are given in mgs per mil. This is the same as micrograms per microliter. And so when you're dealing with microliters, sometimes you want to think in terms of how many micrograms there are. Well, thankfully, this is the same thing. And so this is also the same as nanograms per nanoliter or grams per liter. So as long as the prefix is the same in one case, it's going to be the same in the other case. And they're going to be the same. I mean, like the conversion, the difference between the scales of the units if you have two different factors, those are all going to be constant when you're dividing by the same factor. So molarity, moles per liter, is the same as micromolar per microliter and millimolar per milliliter. And we can even do things like when they're different units, so nanomole per microliter, well, that's actually going to be the same as millimolar. So where did we get this? Well, nano is 1,000th of a microliter. And so we need to use the 1,000th prefix with our molar. And hence we write millimolar. And so we can see that we have a factor of this 1,000 difference between these two units. And so we're going to, in terms of our base unit, it'll be 1,000 less than that. So hopefully that made sense. If I didn't, I know I didn't explain it very well, but hopefully you can kind of math it out and think it through, and make it make sense to you. Try out some different examples. Speaking of examples, say what if your concentration is in millimolar, so millimoles per liter, and you want to know how many moles there are per microliter. So say you have Y millimolar per liter, we can do our dimensional analysis. We can line things up. So we have 10 to the third millimole per mole, and 10 to the 6 microliters per liter. So let's think about this in our intuitive sense. So we have a concentration that is in millimolar, and we want to go to, so millimole per liter, and we want to go to moles per liter. Well, we're talking, or moles per microliter. So we're talking about a smaller amount of stuff. So we're talking about, we want to be getting smaller, so we're going to be dividing. And that's where this term comes in. In terms of and we're going bigger in terms of the unit we're thinking about. So instead of thinking about slices of pizza, we're thinking about boxes of pizzas. And so we're going to be getting smaller in that sense as well. So both of these are going to be divided. We then line these up, cancel our units. We're left with Y times 10 to the minus 9 moles per microliter. And 10 to the minus 9, we knew that. That's our nano prefix. So this is the same as saying Y nanomoles per microliter. And this comes into play when we're resuspending nucleic acids, such as like those primers you ordered. Often it tells you how many nanomoles there are, and then you suspend that. So in nanomoles per microliter, which is the same as saying millimolar. So if you resuspend that oligo in the amount of nanomoles worth of microliters, then you're going to get a 1 millimolar solution. And If you're wise, so say you have a 50 millimolar sodium chloride solution, well, then there's going to be 50 nanomoles of sodium chloride per microliter. So I will post these kind of help sheets, cheat sheets, whatever you want to call them, but remember the intuition, and remember to keep track of your zeros and make sure your units cancel out. Hopefully that helps you, and be wary with when you're using Excel spreadsheets or something like that, that you're not accidentally introducing extra zeros or losing zeros. Keep track of those zeros, and you will be a heroes.